This is lesson 6.5. Mr. G Math coming at you live, 7202. Halloween. Ow. Volumes of solids with known cross-sections. I know that you are drawn to the pictures on the walls. The ones that say, don't forget the candy. And the one with a whale tail. Or the one with a really fat fish. Or the rocket ship going off. And so on. All of those are projects based on this lesson, 6.5. We will, but not now. It took them about 2 weeks to make those. Like everything, the setup, the first of all to come up with the idea, the integration parts, like all the stuff that you need to go into it. It takes a lot of time on Desmos and so on. So I wish it was like 30 minutes done kind of a project. Someone has to agree to go buy materials and argue about it, and no one brought it, and da. It's a what? Yes. So we'll see. Probably by that time, I'll probably place you in different groups by then. All right, let's read lesson 6.5 together. So I just want to make sure that you know now what this is connected to. You can actually see a physical representation of what we're doing. Because the hardest part of this lesson is to visualize in 3D, right? Can you picture things in 3 dimensions? Because that's what's required for you to do. So, in geometry, I'm going to read what it says. In geometry, you learned formulas for finding volumes of common 3-dimensional solids, such as cubes, spheres, cones, prisms, and perhaps others. Calculus allows us to find volumes of solids whose bases are 2-dimensional regions with an XY coordinate system, and whose heights are formed by cross-sections, most often squares, rectangles, semicircles, or triangles, which essentially stick out from the base. So if you look at the pictures on the poster board, do you see how it sticks out from the poster board? Do you know that all of them were formed with either a rectangle, a square, a semicircle, and so on, if you look really carefully? And they glued those shapes over and over again. So they had to make a choice. Is it going to be a square, a rectangle, a semicircle? And then they used that and they glued them together to make their shape. The x and y coordinate of the actual functions determines the size of each one. So that's why some stick out further than others. But at least you can visualize it on the wall. All right, what are some things you need to know from geometry? Area of a square. How do you find the area of a square? You take one side and square it. How do you find the area of a rectangle? Base times height. How do you find the area of a semicircle? Half pi r squared. Pi r squared would be a full circle, semicircle, 1/2 pi r squared. A triangle? 1/2 base times height. I don't expect you to know this, but you need to know it. What's the area of an equilateral triangle? Is √3/4 sides squared. So in other words, if you know equilateral means what again? All 3 sides have the same length. If you know what that one side length is, you plug it into that formula and you could find the area of an equilateral triangle. So all the rest you know, which is one you need to focus in on to remember? Right? The rest you're good? Let's keep reading on. Volumes of solids with known cross-sections. For cross-sections perpendicular to the x-axis. What does that mean, perpendicular to the x-axis? Do they cross over the x-axis? Or are they in the same direction as the x-axis? So they're in the same direction as the y-axis, right? If it's perpendicular to the x. So and that's going to be important when you read the question, is it perpendicular to the x-axis? Then we're going to integrate with respect to x. If it's perpendicular to the y-axis, we're going to integrate with respect to y. All we need to do to find the volume of that area that's trapped between 2 curves, the A represents what again? The area of the cross-section. And then the challenge will be, what do I plug in for the S in terms of what I need? But we'll get there. And then again, if it's perpendicular to the y-axis, it's in terms of y. So the best way to learn is by practicing, right? It says, find the volume of the solid whose base is what shape? So don't be fooled by the shape here where it's, oh, I see the triangle. The cross-section that you're going to create are what shape? Triangles. Bounded by what? Do you see the line negative 2x plus 2? Do you see the line x equals 0, which is vertical, and y equals 0, which is horizontal? And this is an important part. The cross-sections are what? Squares perpendicular to what axis? To the x, right? So that means, in this case, the bounds A and B are the x coordinates or y coordinates if it's perpendicular to the x-axis. What numbers were put in for you? What's the x values? What's the x value here on the left? Here they intersect, right? Right here and here. The x value here is 0. What's the x value over here? So it goes from 0 to 1. What are the cross-sections made of? What shape? What is the formula to find the area of a square? Side square. Now, next step. We need something to put in for the side. So, first of all, this volume, do you see how I'm drawing lines perpendicular to the x-axis? You have to picture that the shape coming out at you is what shape? A square. And so what I'm drawing is just one side length of the square, and then the rest of the square would be hitting you in the nose. Yes? How would I find the side length of a square no matter where I drew it? Do you notice the square is getting smaller as we're going left to right? But at any point, how would you find the side length? And this is going to be a really important thing to know what to plug in. At any point, it's the y-coordinate. Whatever the y-coordinate is, it would give you the size of that length, correct? Yeah. Whatever the y-coordinate is, that would tell me the length. But I don't want to plug in y because it's in terms of x. So what's the y that I would plug in? What does y equal? What does y equal? What does y equal? Negative 2x plus 2. So negative 2x plus 2 represents the side length of the square. The y-coordinate does that. Now notice the bottom. What's the bottom again? Is y equals 0. If the bottom was not y equals 0, and I had two that were trapped, I'd have to go top, subtract, bottom. But if I subtract 0, does it do anything to that? No. So I don't need that top, subtract, bottom, because it's with the x-axis. But if it wasn't with the x-axis, we have to go top, subtract, bottom. So what am I going to plug into the parentheses is negative 2x plus 2. What this integration is going to do is it's going to add up the areas of every single square that's formed. And there's actually an infinite number of squares. And when you add them all up, it's going to give you the volume. That's the big picture. And that scratches your head a bit, right? That's going to take some time to visualize. So I tried to draw as many squares as I could, right? The base. There's actually an infinite number of squares. That integration adds up every area of the square. And if I go square, 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 and put it together, it now becomes the volume. If you want to see a picture of like square, 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 and all that becoming the volume, look at the pictures on the poster board. That's how they found the volume. They took all of that and added them all together. Calculus allows us to add up that infinite number of those shapes. So it does the work for us. So I don't got to add, then add, then add, then add, and so on. Jerry?
When you say squares,
I don't see any square, right? I'm trying to see which one might be squares. I think the one that looks like a guitar there is squares, but it's perpendicular with the the y-axis, going the other direction. All the rest, they fell in love with semicircles for some reason. Okay, let's keep going. Hey, how do I integrate this? So there's the setup. Now how do I actually find the volume? So to integrate this, what's the derivative of this base? Negative 2x plus 2. What's the derivative? Is there a negative 2 in front? No. So if I put a negative 2 there, what must be in front of the integration so it's equivalent? Negative what? So negative 1/2 in front. Then what do I do with the exponent? And that becomes now what? And then what do I put underneath? And I'm integrating from where to where? 0 to 1. Keep going. I'm going to take out another piece of paper because I'm going to run out of room. Do you know that negative 1/2 divided by 3 is the same as negative 1 over 6? I'm just going to keep that in front. What number do I plug it first, the 1 or the 0? 1. Let's just do it. Then what number do I plug in?
0.
And then I answer it. So we have a negative 1/6 in front. What's negative 2 times 1? Plus 2.
0.
And 0 cubed is 0. What's negative 2 times 0?
0.
Plus 2.
2.
And 2 cubed is
8.
0, subtract 8. And negative 8 and negative 1/6. A negative times a negative is positive, and it's 8 over 6. You could write that as 4 over 3. You could write it as 1 1/3. I don't care. What's the volume of that section using cross sections? 8 over 6. The more we practice, better we'll get. But I need to know that you understand the big picture of how we're finding the volume. And that's going to happen by practicing. Okay? So when I looked at what I did in number 1, let me remind you that we formed a volume by using squares that's trapped between the line and the horizontal axes. And I made a square, a square, a square all the way down. A square that would hit you in the nose. Okay? And to find the area of a square, the formula is s squared. And then for s, what did I plug in that represents the side length at any point? The y coordinate. I plugged it in, and then I integrated. And that's how you find the volume. Yes?
Can you explain more about cross sections?
So what does it mean by the word cross-section?
Yeah.
So if I cut the volume at any point, the shape I would see looking at you would be a square.
Okay.
That's what it is. Like if you had a loaf of bread, right?
Yeah.
And you take it out, whatever that's the cross-section, what it means. You literally cut the shape, in this case perpendicular to the x-axis, and then you look at the shape right at you. And what shape are you looking at? And the shape could be a square, a rectangle, a semicircle, and so on. And what's the calculus setup? Understand the formula, and then understand it's going to be the y coordinate that you're going to plug into the formula, and then you have to do the integration. So what's the formula? What's the y coordinate to plug in? And then do the work.
All right.
Here we go.
So
Yes?
if it was perpendicular to the y,
If it was perpendicular to the y-axis,
you would plug in the x, or
you plug in y coordinates. So if it was perpendicular the other ways, it means sideways, you'd have to use y coordinates. And then this equation up here, you'd have to rearrange and know what x equals, and you'd have to plug in terms of y. Okay. That's only one. Do you think you learn everything in like 2 minutes in calculus? So 2, either, right? Set up. Here we go. We're setting up, but we're not integrating this time.
Lord has blessed.
Yes. Integrals for the volumes of solids with the same base as in example 1. So in other words, we're going to use the same picture in example 1, but we're not going to use squares. Now we're going to use other shapes. So what's this shape here? So again, we're integrating from where to where? I'm going to write what the formula is for a semicircle. What is it? 1/2 pi r squared, right? Now, instead of r, I'm going to put in parentheses and then dx. Now, can you picture not a square coming at you? Can you picture a semicircle coming at you? Yes or no?
No.
You got to be able to picture a semicircle hitting you in the nose. Okay, because what I'm going to ask you this is the y coordinate there. You know that what was a square? That line there? It represents not the radius, but the diameter. Why is that important? Do I put the diameter in the formula? No. You need to know the diameter is twice the radius, or the radius is half the diameter. So if the diameter is what? Negative 2x plus 2. I don't want negative 2x plus 2. That's the diameter. What do I want? The radius. Well, how do I find it? Take the diameter and divide everything by 2. What's negative 2 divided by 2? And what's 2 divided by 2? So what describes the radius for every semicircle? Negative x plus 1. There's the setup. We're not going to integrate right now. Do you know what you could also do? That 1/2 pi, which is pi over 2, could go in front of the integration, and you just tack that on at the end after doing the work. Do you feel tired today?
No, it's the part, the picturing part is confusing. Like the math part is alright, but
I get you. And then I told you that, right? It's going to be that kind of lesson today. It's going to take time. The hardest part is to visualize the 3 dimensions. Here we go. You ready? What's the next shape? So again, we're going to integrate from 0 to 1. How do I find the area of a rectangle? Base and height. And it says, sorry, perpendicular to what axis? To the y. So now I'm not going to use, well, I am going to still use 0, but not 1. Do you know what the y value is way up here? Oh, let me bring it down. What's the y value way up there? So it goes from 0 to 2, and these are going to be y values. It says the rectangles of height. What's the height of each rectangle? So that means one of these parentheses is simply going to be what? 1/4. This is terms of d what again? dy. And then what goes here is what the base is. So now, will you allow me to redraw what was above? Remember this right here? Like it's the same picture as above, right? But this time, what direction are the rectangles going? Okay? So what I need to know is what represents the base of the rectangle no matter where I draw it. The what? The x. Now, can I put x here? No, because it's in terms of, I need to know what x equals. Well, what is it? What's the equation to begin with? Y equals negative 2x plus 2. Can you tell me what x equals? What is x when it's by itself? Don't make it complicated. Instead of adding 2, what will you do? Instead of multiplying, what will you do? Don't simplify it. It's y subtract 2 divided by what? Done. What happened? Go for it. I'll be there. I'll give you candy as long as you're with a little person. No teenagers should do it by themselves. It's not their time. But if you're going to keep a little one safe tonight, that's what you do. It's not for teenagers to go door to door. You can argue me all you want. If you want to go door to door, there's plenty of little ones that need your safety tonight. Take a little person and go. No jokes about little people in the classroom. That's it. That's right. Mariana doesn't need your help. Here we go. Number 3.
What if I take my dog?
Nope, doesn't count. 3. But you should keep your pets safe too tonight. Set up. Don't set up, but don't integrate. Shh. An integral for the volume of a solid whose base is bounded by y equals negative x squared plus 2 and y equals x, and whose cross sections are what shape? Perpendicular to what axes? So already in my head I go, okay, square, the area of a square is what? X axis means the integration is going to be in terms of x. Perpendicular to the x-axis means in terms of x. Now, what don't I know that I need to know is where do they intersect and what does the picture look like? Let's do it. So that would be negative x squared plus 2. Aren't you glad we're meeting Monday after school?
No, I'm not.
We're going to miss you. I miss you. I hope you're here. I want you to be here because we have 2 more lessons, Tuesday, Thursday, and then a test next week. So negative x squared plus 2 and x. How do I solve that equation? Make it equal to? 0. So I'm going to add x squared. We have positive x and subtract 2. That's the same as x plus 2, x minus 1. So x equals negative 2 and positive 1. Do I need to know the y coordinates for the setup? No. So it goes from negative 2 to what? To positive 1. Small to big. Inside will be the area of a square, which is what? S squared. Inside, what will represent the side length of the square or the base length of the triangle or the whatever is the y coordinate. What does the y coordinate? What does y equal? Well, in this case, it's actually going to be not trapped with the x-axis. So we need a picture to know what's on top and bottom because we need to subtract top from bottom. Here we go. What would happen if you sketched it? What would it look like? What would y equals x look like if you sketched it? Like how? Like how? I haven't done anything. I've just drawn like 2 fancy lines.
It'd be like a
straight line. I like that. So let's pretend y equals x goes through 0, right? And it's up 1 and over 1, right? Hey, at what points do they intersect? At negative 2 and where else? At positive 1. What shape is negative x squared plus 2? So it's a concave down parabola. Plus 2 means it's been shifted up 2. So the vertex is actually at 2. If we draw this so they intersect, can you see the line in the parabola? Do you see this part here? Where the parabola and the line, right? If I asked you, what represents the base of that square from top to bottom? What I want you to recognize is you're going top, subtract what? Bottom. So you're going negative x squared plus 2, subtract, what's the bottom again? That's what you put inside the parentheses. Top, subtract bottom. When we go top, subtract bottom, the difference is the length for the base of that square. So altogether that would be negative x squared, negative x plus 2. And there's the setup. All right, turn the page. I know, you are in awe today. I feel you guys are sleepy or it's heavy or what. I don't know. We only got one more example, okay? You know that I know that you're not learning right now. You're just setting up your brain to learn later. It's just a setup. I'm putting the ball on the tee, right? And you still got to set up and hit that thing on your own. But we're not learning it right now. I'm setting up the learning right now. All right, let's read number 4. It's our last example together. And then where do we learn is when we practice. And when you practice together, it's even more powerful. And on Monday after school, we're practicing together. If you can't, you can't. And if it ends up that most can't, then we won't do it, right? But if most are here and it matters to you, Monday after school, next Monday, we'll make a regular habit of Mondays or our time. Lunch, everybody's here, right? It's crazy. But Monday, I'll kick everybody out. It's only me and my calculus friends. 4. Set up integrals for volumes of the solids. Let's see what matters. The base is what? So do you see the circle here? X squared plus y squared equals 1. We are going to find cross sections, and it says equilateral. What shape is it? And it's perpendicular to what axis? Don't guess. We're setting up the integration in terms of y. We are setting up the integration in terms of y. The bottom one says, again, perpendicular to what axis? In terms of y. What is the area of an equilateral triangle? And it's okay to look back.
Hey, come on.
Now, perpendicular to the y-axis means we're going in what direction?
That's right.
That direction. And what's hitting you in the nose? Are equilateral triangles. I need to know the length of that one side. All the sides are the same length for an equilateral triangle. But that one length will give me the area. So I'm integrating from where to where? Am I using y coordinates or x coordinates?
Y coordinate.
So what's the lowest y coordinate?
-1.
Good. Did you know that or guessed it or just thought it looked like that off the graph? Look at the equation. X squared plus y squared equals 1. The square root of 1 gives you the radius, right? In all directions. So we are going from -1 to what?
1.
To +1. What's the formula for an equilateral?
The square root of 3 over 4 times x squared.
Now, why did I put parentheses in there? I need to know, is it right subtract left? Yes?
Yes.
What is this in terms of y? What does, or x, I mean, what does x equal so I can put it in terms of y? So first of all, we have x squared plus y squared equals 1. Do I need to solve for x or solve for y here in this situation? X. Because I need to know what x equals, and then what's there on the right would be y to plug in, right? I need to know what x is by itself. The x values give me that, what I need. But I need it in terms of y. So how do I solve for x here? So that would be 1 minus y squared. Then what would I do? Do you know when you solve a quadratic, the answer could be positive? Or the answer could be negative. There are 2 equations here. The positive is the right side of the circle, and the negative is the left side of the circle. And together they make a full circle. The positive root 1 minus y squared is what part of the circle? The right. And the negative is what side? The right side. If I said graph x equals that, it would be half a circle on the right. If I said do the same one, but it's negative in front, that would be half the circle on the left, and together they make the whole circle. So in other words, which one's on the right? The positive or the negative? The positive. Which one's on the left? And there's the integration setup. Right subtract left. But in order to do right subtract left, I needed to solve for x to know what x equals, and then recognize that when you solve it, you have 2 halves that make a whole. The positive and the negative. And then when we find the length of the base, you go right, subtract, left. All right, B. Rectangles whose heights are what? 3 times their bases, and whose bases, again, are perpendicular to the y-axis. We've already done all the hard work. We can now relax. You ready? We're integrating from where to where again? -1 to +1. A rectangle is height, base times height. So I'm going to go base times height. And it's in terms of y. What is the base? What describes the base of the rectangle? We already did the work. The square root of 1 minus y squared, subtract negative the square root of 1 minus y squared. We already did that one. What's the relationship between the base and the height? The heights are what? So guess what I write down? And then I write it over again. So, I know that this is challenging. But can I tell you the parts that are most challenging is to come up with an expression that describes the base length, right? The challenging part is that part right there. Is it easy to find the bounds on the integration?
Yeah.
Is it easy just to see what area formula we're going to use? What's the challenge? To find an expression that describes the base length. Because once we have that, we just plug that in. And it's over. And we could use our calculator here. So I set it up. You haven't learned it yet. So now you need to learn it. This could well be something on Monday we need to keep focusing in on, right? So that when you have a test next week, you're prepared to do well on that test.
So are we continuing this lesson on Monday?
We're going to do some, but we're also going to have a quiz. And we have another lesson on volume on the next one. I know. On Thursday. Happy Halloween!